Okay, so I've got this racetrack here in question 9 that's made up of a rectangular shape, 750 meters by 500 meters, with semicircles at each end, as shown in the diagram. So Lewis drives around the track once at an average speed of 140 kilometers an hour. So for part A, we need to calculate the distance that Lewis travels in kilometers. So just bear in mind our units currently 750 meters, 500 meters in meters. So at the end we'll need to convert our answer to kilometers. So we'll start by working out the distance or the circumference of this semicircle here. So we know that the circumference of a circle is pi times diameter. So therefore we're going to have 500 pi, because our diameter is 500 meters, and it's only a semicircle, so we'd times it by half, but we've actually got two of them. So we've got this one here, which is exactly the same, so we'd times that then by 2, which cancels out, so we just get 500 pi. So that's the semicircles done, and then we just need to add on these parts here, the 750 meters, and that is also the same there. So then we get 750 times 2, and that is equal to 1500. So therefore the distance is equal to 500 pi plus 1500 kilometers. So that would be the exact answer. But if we just get our calculator out, we can work it out and round it to 3 significant figures. So we have 500 pi plus 1500, and that is equal to this 3070 point, and then a bunch of stuff after that. So just remember that is meters, and we need the answer in kilometers. So if we divide this by 1000, so we'll put meters there, we're going to get 3.07, and then it's 079, and then a bunch of other stuff. But we're going to just round it to 3 significant figures. So our first significant figure is 3 here. So we count across 1, 2, 3. Look at the next number, it's just a 0, so we round down. So in this case, the answer then is just going to be 3.07 kilometers. Okay, so that's the answer to part A. Okay, so now we'll look at part B. So if we just scroll down, we need to calculate how long Lewis takes in seconds. So if you remember the formula, we know that speed is equal to distance over time, and we want to find out the time. So if we multiply both sides by t, then we get ts is equal to the distance, or the time is going to be equal to distance divided by speed. So we know our distance, that's 3.07 kilometers, that's the distance around the track. And we know our speed, that was given in part A, or before the question, as 140 kilometers per hour. So now we can work out the time. So just be mindful, we've got the right units here because we've got kilometers for our distance and kilometers per hour for our speed, so that's okay. But just remember the final answer needs to be in seconds. So as we work out our time, our answer is actually going to be in hours. Then we'll just need to convert that into seconds. So we have our time then is going to equal our answer from part A, that's 3.07, and we divide that by 140, and if we get our calculator back out, we have 3.07. You can use the full answer if you want from before. It doesn't really matter. It's probably more accurate doing it with the full number, but it won't matter as we round towards the end, and the main goal here is to get the method correct. Okay, so we have 3.07 divided by 140. So that is equal to 0.0 and then 21928 and so on. And just remember this is in hours, so we can write hours. So to convert to seconds, we need to multiply by 60, that'll get us into minutes, and then multiply by 60 again to get us into seconds. So we're going to have then 0.0219, etc. times 60, that'll get you from hours to minutes, and then times 60 again to get from minutes to seconds. So we can just keep that answer on our calculator and have times 60 times 60, and that is equal to 78.94, and it goes on there, but we just want to round to 3 significant figures, so we're going to have 78.9, and the answer is in seconds. Okay, so that is question 9.